This is Yanis Kaf for Sensor Technology Task 3. For this task, I've combined the projects from both Task 1 and 2 to make an even larger project. I now have 3 ultrasonic sensors, which are controlling parameters in a max patch, and also controlling the speed of the 6 servos. I also have 1 potentiometer, which is controlling a parameter in the max patch. So I'll go over to the code. Most of the code is from the 2 first tasks, but it's been merged together, and I've had to do a few things just to get everything to work together correctly. First we have we include the servo. Then we have the 3 ultrasonic sensors. You'll notice that I have a 4th one here, which I've commented out. This is because I've quickly realised that you can't use the 0 and 1 pin when you have a serial definition here. When you have the serial print, for example, you can't use the 0 and 1 pins, so that's why I've added a potentiometer instead. Then I've named the servos 1 to 6, the positions, same as task 2. The intervals, you'll see I've tried to label everything as neatly as possible. You'll see each servo now has 2 servo intervals, whereas previously there was just 1. This means I can swap between 2 different times. So here we have 500 milliseconds and 250 milliseconds. I've decided to keep each servo the same, although you can change this if you want to have variations. I just preferred them all to be similar speeds, or times rather. We then have these servo timers, like task 2. In the void setup, we've set up the 6 servos. You'll notice that each one has a random pin rather than being in order. They're a bit randomized. This is because the servos need pulse width modulation, and the ultrasonic sensors just use regular digital pins. Next, again like task 1, I have the output and input there. To actually move the servo, this is exactly the same as in task 2, just perhaps a little bit tidier with the with the dividers. Then going on to the void loop, I have this again is the same, but I now have 3 of them because I have 3 sensors. And what I've had to do is change the duration and distance to be numbered. So we have sensor 1 is duration 1 and distance 1, sensor 2 duration 2 and distance 2, and so on. I won't explain how these work because I explained that in the previous video. And now going on to the servos, this is the loop that controls the servos, and this part here may look familiar. This was taken from the old code. What I've had to do, in order to switch between the servos, I've put this if statement within an if statement. So this is effectively saying if distance 1 is lower than or higher than 30, then play interval A, else play interval B. And you'll see here that I have servos 1 and 2 are controlled by sensor 1. So both sensor 1 and 2, servos 1 and 2, are being controlled by the same sensor. So I have servo 1 saying if else, then servo 2 if else, and then moving on, servos 3 and 4 are controlled by sensor 2, and 5 and 6 are controlled by sensor 3. And then finally we just print the distance and the potentiometer reading, and this is so we can see what's happening in max. So moving over to the max patch, this is the same patch that I used last time, but it's been expanded upon. Everything has been put into, they've been encapsulated into these. So if I click this, you'll see here exactly the same as the last patch, and I'm using send and receives instead of and having everything encapsulated. So each one of these channels are the same, they're duplicates. So I now have three channels, and here you can load sample channel 1, load sample channel 2, load sample channel 3. So each one now has a delay effect, which I'd started work on the last project but didn't finish. Here you can see a simple on-off switch, so all this does is changes which volume is. This is the dry signal, this is the wet signal, and it just flicks the volume level on each one. The dry signal goes straight to the mixer, the wet signal goes through a delay and then to the mixer. The mixer is simply just a way to control the volume of each channel. If one channel is particularly loud, you can turn it down, turn the other 2 up. Then all 3 channels lead to the main delay, and this is just exactly the same as the last delay, but this doesn't have the option to turn it off and on because this is a main feature of the synth. And then from there it goes into the master gain. Finally, the simple serial, you'll see here, I've made a few changes from the older patches. I've changed the multiplication here, so you can see this is times by 0.25, and these 3 are times by 1.5. I've also changed inside the encapsulation. I've now used the split object. What this allows you to do is, this is effectively an if statement. It's saying if the value is between 1 and 200, or whatever values you set, then send that number to the left box. If it's not between this value, send it to the right box. Then all I have to do is take this data, I know it's between 1 and 200, then I can send it to my if-else statement and to my number gates. These three here are all being used to control each granulator. So this one here is being sent to dial 1. I scroll back up, go into granular 1. This is controlling the metro amount. So if I turn this on, just to demonstrate, you can see that's being manipulated by my distance of my hand from the sensor. Just turn that off, and all three of these do the same. If I turn all three on, they're all being controlled and manipulated, and there's just some extra layers there compared to the first task. The last one here is dial 4, which is the potentiometer, and this is controlling the delay time of the main delay. So if I turn the potentiometer, you'll see that changes, that varies there. So now I'll move over to the hardware and demonstrate what's going on over there. Okay, I just wanted to do a quick demonstration of the wiring for this project, because once I get it in the box it's going to be quite dark and cramped in there. So although this looks quite messy, it's far more organised than it looks. As you can see, everything's labelled, so I have sensor 1, sensor 2, sensor 3, nothing's actually plugged in yet. I then have the potentiometer, which no need to label that. Then I have servos 1 to 6 all the way along here. And both breadboards are powered by, or turned on and off by, independent switches. I've also added some LEDs because it's going to be dark inside the box, so that's just so I can see easier. If I move over to the hand-drawn schematic here, you'll see I have breadboard 1 powered by a YW robot. Breadboard 2 is powered by the Arduino. Both are linked on the ground. I then have, in order to distribute the power evenly, I've got servo 1, 2 and 3 on breadboard 1, 4, 5 and 6 on breadboard 2. Breadboard 1 also has sensors 1 and 2, breadboard 2 has sensors 3, and the potentiometer that was, as you can see, was sensor 4. I also have, to match up with the labelling, I have the pins for that everything is plugged into. So sensor 1, trigger pin is pin 2, echo pin is pin 4, and so on. I also have the servo pins, 1 is 3, 2 is 5, and as you can see. The reason these are all odd numbers is because the servos need to be powered by pulse width modulation. And that's everything. Oh, and here I have the servos, which haven't been plugged in yet, but they're all glued and ready to go. Okay, a quick update. I've actually had to add an extra power source and an extra breadboard to power the ultrasonic sensors because the servos seem to be drawing too much power from the two power sources already. So I've extracted a battery bank, or a little battery pack, from an old toy, and I'm running 3 AA batteries, which is about 4.5 volts, which seems to be enough to run the ultrasonic sensors and the potentiometer. Just a final overview of the finished project. Here there's a switch that turns on these 3 over here, and there's a switch over this side, turns on these 3. And they're a bit slow at the moment because these aren't plugged in. And then we have the 3 ultrasonic sensors on the front and the potentiometer just there.